Hello everyone, my name is Zhiqiang Duan, the Deputy Chief Engineer of CRC Yongji Electric. It's a pleasure for me to take this opportunity to share the key technology and development trends of high-power offshore wind generator with you. I will divide my presentation into three parts. Founded in 1969, CRC Yongji Electric is a co-subsidiary of CRC Group. It specializes in the R&D, production, manufacturing, and service of wind generators. In 1998, Yongji developed the first 600 kW cage-type wind generator in China. Today, its products cover the four technology platforms of SDIG, DFIG, direct drive, and hybrid, with a power range from 600 kW to 12 MW. Yongji Electric has provided more than 40,000 wind generators, and its products have been installed in more than 1,600 wind farms at home and abroad as of the end of November 2020. Yongji Electric generators account for 30% of the total operation in China, and the domestic market share is the first. Offshore wind power started in Europe in the early 1990s. Many countries have formulated ambitious development plans for offshore wind power, and it is estimated that 205 gigawatts will be newly installed by 2030. However, there is still many problems for offshore wind power. Yongji Electric will promote its goal from the following three major technologies regarding how to make better use of technological innovation and constantly break through key technologies to ensure that offshore wind power is advancing towards the goal of integrated development and new generation of power. On October 12, 2020, Yongji released 12 MW hybrid PMSG for offshore application, the largest power level of such technology in the world. This generator has the features of high efficiency, low harmonic content, high power density, and strong maintainable ability. The first key technology is optimization design of electronic scheme. Double winding backup design is adopted. One winding can still work independently while the other fails. Low torque position design is adopted. Air gap size, minimum and maximum air gap size ratio, groove size, power arc confidence, etc. are optimized. The second key technology is fully sealed and modular magnetic pore structure. Magnetic pore structure adopts four sealed structure and adopts special anti-corrosion structure. It has pulsed damped heat, salt sparing, modes, high and low temperature impact test to improve the operation reality under harsh working conditions. This generator adopts high efficiency double cooling design. The stator adopts the innovative vortex cooling structure, and the rotor pore adopts air cooling, which improve the power density and reduce the generator size. The fourth key technology is reliable insulation structure and anti-corrosion technology. H-class corrosion-resistant insulation structure is adopted for the insulation, which enables the generator adapt to higher voltage change rate and peak voltage of the converter. The insulation system is developed based on the insulation structure applied for nearly 40,000 wind generators in Yongji, passing the test of salt fork, damp heat, moist, high and low temperature, and satisfying the offshore working conditions. The key parts are made of low temperature resistant materials and vibration resistant materials, which improve the low temperature and the vibration resistance of the generator. Next is the squirrel cage technology. On November 15, 2020, Yongji Electric successfully rolled off the production line of 6.x megawatts squirrel cage asynchronous generator, which is the maximum power level of such technology in China. Two key technologies are adopted in the design of this generator. The first one is lean R&D and precise design. The second key technology is multi-field cooling optimization design technology. Is adopted to ensure the low vibration, noise, temperature gradient, and the temperature balance between the front and the rear bearings. The next is about the direct drive segment technology. On November 15, 2019, Yongji Electric successfully rolled off the production line of 3 megawatts centralized winding modular direct drive permanent magnet generator. The successful development of this generator represents the leading technology level of the high power segment DD generator. This generator adopts centralized winding with short coil and low copper consumption. The temperature rise is low and the power generation efficiency is high. The centralized winding has the advantages of simple winding operation, no completed stretching at the coil ends, short production cycle, and high reliability. It adopts the modular production mode. The single stator module has small volume and light weight, which has light volume requirements to VPI and baking equipment. As the proportion increases, offshore high-power wind energy also brings challenges to us. In the future, only continuous technological innovation can effectively guarantee the high-quantity development of offshore wind power. 5 years from 2015 to 2019, the proportion of global newly installed offshore wind power capacity has increased from 5% to 10%. In 2019, China's newly installed offshore wind capacity reached a record of over 2.4 gigawatts, accounting for 99% of the global newly capacity, ranking the first place. For the moment, wind turbines with power range from 5 to 8 megawatts will be the main models. 7 to 10 megawatt units are gradually mature. The 10 to 15 megawatt prototypes will be launched in succession. For offshore wind turbines, due to the harsh offshore construction conditions, the cost of foundation construction and hosting of a single unit is much greater than that of onshore units, resulting in high construction costs for offshore units. However, large capacity units have certain advantages in reducing the total investment of wind farms, so the high power offshore wind turbines is the research direction of the industry at present. 18% of the world's offshore wind resources are located in waters with a depth of more than 60 meters. Commercialization of floating wind turbines as soon as possible has become an urgent task for the wind power industry. Compared with the traditional fixed wind turbine, the floating unit has the characteristics of large vibration, acceleration, large inclination angle, and wide range of installation inclination angle. Therefore, the impact load bearing design of structure parts of the floating wind turbine and bearing selection design will become key technologies for future developments. Intelligent wind turbines will develop into 3 technology directions of online monitoring, fault prediction, and health management. Utilize wireless sensors and wireless transmission technology to open up the 5 links of information collection, transmission, storage, cloud sharing, and visualization to realize a holographic perception. Adopt deep state and artificial intelligence algorithms realize the failure prediction through autonomous learning by computer completely. With the development trend of increased power rates in offshore winds, we have to monitor the running status of generators to avoid huge losses. Finally, we are committed to providing customers with high quality and efficient offshore power generation systems. Thank you.